Welcome everyone to day 2 of Aerospike's Digital Summit 2021. For those of you who were with us yesterday, welcome back. For those for who this is the first day of the event for you, welcome. We're glad to have you with us. I am the CMO of Aerospike. My name is Bill O'Dell, and I'll be walking you through just a few housekeeping things this morning before I turn it over to our keynote speakers. Speaking of our keynotes, right after my remarks, you're going to hear from two different sets of speakers. One is Srinivasan, Aerospike founder and chief product officer, and he'll be sharing with us all Aerospike's innovation agenda, including some news we put out today. So you're going to want to stick around and hear what Srini has to say. And following Srini, you'll hear from our customer Cybereason. You'll hear from Lior Moselle, Cybereason's Senior Vice President of Engineering, and EVTR 10. Cybereason is director of their data platform. And you'll learn how they are using real-time data to fight cyber attacks. So please stick around and listen to this morning's keynotes. Now, I want to make sure you mark your calendars for an end of the day meetup we're going to host. We're going to have some fun today. Today is Cinco de Mayo, and we're going to celebrate that by having a celebrity chef with us share a recipe for making high-performance tacos. And if you haven't figured that out, that's a play on real time. So please stick around and have some fun. He's going to actually cook those tacos for all of us and share with us the recipe. So for any of you who are out there who are foodies, please make sure you stick around and have some fun with us at the end of the day. Now, I want to remind everybody that you can win some prizes just by sharing your experience with us today on social media. So if you have a LinkedIn account or a Twitter account, please log in during the event and share your experience at some of the sessions, the things that you like, the things that you learned, have some fun with it, take a picture, whatever you can do. Go out there and spread the word. You can see the social media hashtags we encourage you to use. If you use those hashtags, we'll be able to track what you're doing, and we're going to give out some prizes based upon everybody who shares social media. I want to make a note of the prizes. One is a Lego rocket. We give this away every single year. It's one of the most coveted awards and prizes we give out. So if you share on social media, you can win an Aerospike rocket. And we'll also be giving away some of the, what we call baby Yodas, which was part of yesterday's meetup theme, which was May the 4th be with you. So have some fun on social media and win some prizes. Now, I want to say again that we couldn't have this event if it weren't for the generosity of our sponsors. You can see them listed here. A special call out to HPE and Intel and Western Digital for being gold sponsors. Thank you for your support. But please note all the other people that have made this event possible for all of us, and take some time during a break, or if there's a session that you're going to skip, please stop by and visit their booths. They're all there ready to talk to you about what they can do to help you with your respective projects. So thank you to our sponsors. Please visit them. And with that, I want to introduce our opening keynote today. Srinivasan is the founder and the chief product officer here at Aerospike. He is a database luminary. He holds multiple patents. He is well known around the industry, and he is the brains behind the Aerospike real-time data platform. He's going to be sharing with us all Aerospike's innovation agenda, including some news we put out today. So with that, I want to turn it over to Srini, and Srini, take it away.
Let us consider how AI/ML processing works with Aerospike deployed in an edge core architecture. Aerospike, as you know, is deployed heavily in high performance environments on the edge, where it uses the hybrid memory architecture. Aerospike most recently has also been deployed as a system of record, which gathers all of the data available in all of the edge systems that Aerospike runs using the cross data center application that is also supported by Aerospike. In addition, Aerospike has support for various connectors, especially the two that are really important for AI/ML processing are Spark and Presto. And what these connectors to Aerospike allow applications to do is to run complex AI/ML processing through Spark with the data being used in place from Aerospike. And such processing can be done in parallel and can handle petabytes of data. If we look at Aerospike 5.6, which we have announced today, it is a real-time data platform that gives enterprises instant access to petabyte scale datasets. In our release 5.6, there are a lot of improvements to query. The first one is set indexes that provides efficient access to a set within a large namespace. This means querying records within a set can happen really fast, as well as we have added enhancements to expressions in Aerospike. Expressions have been supported for quite a few releases in Aerospike in the database 5 series. What we are doing now is extending expressions to also handle read and write operations. It allows better querying, of course, but also the ability to move the processing closer to the data. We'll see a little bit more on that in a second. Additionally, Aerospike has supported Apache Spark with the Connect for Spark product. And what Aerospike recently added was support for Spark 3.0 applications. What this means is a combined system with Spark running against Aerospike using these query enhancements, including set indexes and expressions, can improve the processing rates of large amounts of data using Spark. Let's see a little bit more detail of what Aerospike Database 5.6 supports. Our big focus in 5.6 and throughout this year is going to be query. Aerospike expressions are adding support for read and write operations, which means we can enhance the multi-operation transactions using various operations that can happen as part of the single transaction. And this can happen as part of a query, which means the processing can be done on the server. The concept and query language has a familiar look and feel for developers. It is also better performing than UDFs because these operations are going to be executed on the server in C code. All of this allows processing closer to data. It increases efficiency, which means you get better performance at scale, and so on. We also support in 5.6 auto-indexing of objects in a set. This will enable easy access to all of the objects in the set, and using expressions with set accesses means that you can actually have a very fast way to access small sets within a large namespace and then run a filter on top of that. This is actually the first part of a year-long effort we are starting to improve secondary indexes. And such a processing of sets is going to be faster and more lightweight than traditional secondary indexes. Additionally, there is a new feature we have in 5.6, which should help multi-tenancy. We are able to enforce quotas for transactions on a per user basis. This applies to, you can actually specify specific read and write rates to cap a user. Also, this applies to single record transactions, which can be reads and writes, batch reads, scans, queries, etc. Combined with Spark, the features of Aerospike Database 5.6 improves the performance of analytics integrations that rely on table-level scans and queries. So this will speed up Spark, Presto, and pretty much any table type workloads. Also, Aerospike Connect for Spark recently added support for Spark 3.x APIs. And this is going to make sure that Aerospike data can now be efficiently queried and scanned for data processing. And the key is without an additional copy to external systems. So what you can see on the bottom left is a picture of how the Aerospike database acting as a system of record, which basically collects data from all of the edge databases, can be integrated with Spark and also Presto, which means you can now run SQL queries from Presto against Aerospike. Additionally, something that Aerospike has supported for a while is the ability to scan partitions in parallel. So it is possible, as shown in the picture on the bottom right, a Spark cluster running 32K worker threads to access data in Aerospike using 32,000 parallel streams, which essentially you have about 8 substreams per partition. So Aerospike scans can actually provide that kind of alignment between the scans in Aerospike and the processing in Spark. This allows very fast processing of large amounts of data. So the kinds of features we are working on this year, with the first installment being Aerospike 5.6, is going to help improve the feedback loop between model generation to model execution. Most of the Aerospike customers run their evaluation of the model on the edge, and they also have the ability to generate new models based on the data in the core database of the system of record. So the cycle goes, as is shown in the right of this picture. You generate a new model based on the system of record data, update the models on the edge, and then the real-time model, of course, is applied at the edge for various transactions coming in. And then you feed the latest activity from the edge into the system of record, which can be done using XDR. So the movement of data between the Aerospike data on the edge to the core and the core to the edge can all be done using cross data center replication. And then once the latest activity is fed into the system of record, you can now run a new model based on the system of record using Spark processing. So Aerospike's philosophy is not to implement all of these complex processing inside the database. We therefore interoperate with systems like Spark that do an extremely good job of performing these kinds of data processing. And our contribution is to leverage the high performance at scale of Aerospike to help speed up these processings that happen to generate new models. Now, the basic impact is, first of all, we've sped up the model generation at scale. So if you have tens of terabytes of data, you can generate new models by looking at all of the data using your Spark process within an hour or two. The second thing is we've now improved the cycle time between generating a model and when that model can be applied on the edge, and then when the new data can show up basically in the system of record, so you can redo your model or improve it. So that cycle can be reduced from weeks and days, as seen in many deployments today, to hours or minutes. And all of this is in addition to the work that Aerospike has done over the years to help ingest data into system of record in real time. So we have provided various support over the years for storage technologies like NVMe SSDs, Intel's Optane persistent memory, and various other enhancements which allow you to ingest data in real time into all your databases. And XDR allows you to move the data back and forth. Now, in this release, we are adding some support which moves processing closer to data. So what this means is your scale is increased, some more in terms of how much you can process within the same amount of time budget that you have. A lot of the Aerospike deployments are based on SLAs at the application level. Now we are just bringing more stringent SLAs on even more larger amounts of data that can be now essentially provided to applications. So set indexes do that, expression enhancements do that, because we can run some processing with the expressions, as well as the Aerospike Connect for Spark can push down various set-oriented queries into the database, for example, for better performance. Now, in terms of improvements for the future, it is going to be impacted in a positive way by the query enhancements we have planned for the rest of the year. Now, let's just talk a little bit about what's next. The big focus in the database for the rest of 2021 is query. As I described already, we've released 5.6 with support for set indexes and expressions, and enhancing support for expressions by allowing operations to be executed there. Going forward, in the next phase, we will be revamping secondary indexes. First, we will focus on secondary indexes performance. Performance improvements are going to be both faster lookup, but also the ability to, and some of it is the result of reducing the index entries by almost threefold in terms of storage sizes. And the way we are storing indexes is also going to change. So instead of having an additional lookup that's going to happen, index entries can now point directly to primary index entries, which enables us to get better performance for secondary indexes, and also make it easier to garbage collect deletes, especially when the index entry when the indexing attribute on the record changes. Then what happens is you would have to do an add and a delete on the corresponding index, and this is something which we can do in real time with the changes that we are planning to do. Moving forward to the next phase, in phase 3, we will focus on secondary index correctness. Essentially, this would improve correctness guarantees, the kind of guarantees that are available for scans today. Essentially, when nodes go in and out of the cluster, the ability to always get the correct data for the query is something which we do for scans today. We will be adding those kinds of features for secondary indexes. This will also come with a good beneficial side effect of allowing query pagination and the ability not only to limit the number of records returned by a query, but also the ability to restart the query from a previously accessed record. This is something really important for large backups, for example, or any query which is returning tens of millions of items, and you may want to restart it if it failed at some point. Finally, on the phases 4 and 5, we will be bringing the secondary index storage models in line with the support we already have for primary indexes. For example, slab-based memory allocation, shared memory support, which will provide a fast start, support for storing secondary indexes in PMEM, and also for supporting secondary indexes in Flash. All of this will enable Aerospike to continue its performance at scale to handle petabyte scale databases with low server footprint, which we are really good at doing right now for primary index queries. We will continue to improve that for all kinds of secondary indexes. Note that secondary indexes are always dynamic, and you can create them on the fly, and you can drop them on the fly, just as you would expect. There are other features we're working on in the database. I'll just point out a couple of things. First, the security is important. It's an ongoing request from many of our customers, and we continue to work on this. We've already made a small dent in multi-tenancy by adding quotas on user transaction rates in Aerospike database 5.6. We will be spending more time on additional quotas and stats for storage layers and so on. The idea here is we will support Aerospike running as a data service in some of our large customers, so where they have multiple workloads which essentially have to use the same cluster, and we want to provide the operators the right kind of controls so they can safely allow multiple applications to share the same cluster. And this is also even more important on the cloud. On the enhanced resilience part, Aerospike is working on continuing to support larger and larger scale deployments. We run, for example, several petabyte scale deployments which have millions of reads and writes a second, and these are getting more complex and growing at a really fast pace. And all of this means that with the move to the cloud, there are certain patterns on the cloud infrastructure that are quite different from bare metal hardware. And Aerospike is working on ways to adapt our product so we can run safely and also with high performance on all kinds of cloud environments. Going forward to the ecosystem side, there are a lot of streaming connectors that Aerospike supports. These are typically Kafka, JMS, Pulsar. We also have an XDR proxy connector, which allows Aerospike to be deployed in cloud environments or in environments where there is no visibility of the other cluster. So when XDR typically communicates from one Aerospike cluster to another, we may not be able to see all of the nodes of the target cluster, and the proxy allows us to do that. And this is especially important in Kubernetes environments and so on. So you will see us in the streaming connectors case. These are real-time connectors where data from Aerospike is sent to other systems, and data from other systems is sent into Aerospike. So this is a real-time kind of back and forth through various connectors like Kafka, Pulsar, and so on. Now, if you look at the kind of work that we do, we will be adding basically support for monitoring, support for transformation of data. So it's easy for any application or customers to extend these connectors. So the data transformations, which are specific to the application, can happen in the connector. So we've already released some of that support for Kafka. We'll be adding the transformer support for other connectors. We're also adding certain pieces of connectors, like Pulsar inbound is not supported right now. So we will support that, as well as add similar support for Google PubSub. Also, there is more security-oriented features, as well as containerization of all connectors is really important, and connecting to direct cloud services. Like, for example, the managed streaming service on Amazon for Kafka is something we will add support for, and also support more various formats like protobuf and so on. On the other portion of the connector universe, these are data access connectors like Spark and Presto. We already talked a bit about that when we described database 5.6 features. We will continue to also enhance these connectors, both in terms of adding support for APIs like 3.x. We already have APIs, but we have not leveraged all of the Spark APIs to do, Spark 3 APIs to do more sophisticated things in the connectors, and you will see some of that as expressions. The expressions work that we've done will enable us to do better query pushdowns, as well as more and more work on the secondary indexes that I described will also enable us to improve the efficiency of these queries and processing that's happening on Spark and Presto when it concerns Aerospike data. So you can rest assured that we will continue to improve the connectors as well as the core product in order to enable larger and larger jobs to be tackled efficiently using a combination of these systems with Aerospike. At some point later, we will also be adding support for Flink and other connectors as we get the opportunity or the need for that arises. On the cloud, you might have seen already that we released and launched the Kubernetes Operator. It actually supports a lot of operational tasks, like starting and stopping a cluster, upgrading and downgrading a cluster, configuration validation and updates, and so on. However, we will be continuing to add more features to that throughout the year. And it'll be all about, for example, we're going to certify for OpenShift at some point soon, as well as adding all of the other operational support that is required for running a complex Aerospike system, in production. And all of this, you can see the list here. But the basic idea is, how do we make it all automatic? So essentially, you can have a really well-running database as a service, which is basically the endpoint of all of this work. Finally, on the ecosystem side, we haven't forgotten the developers and operators who essentially are our key users of every product that we release, that we build, and we are going to invest. We've been investing, and we're going to continue to invest a lot of work in both the developer and operation portions. On the developer side, we are working on a data browser. We are improving frameworks. There have been some releases. Some of it will be open source. Some of it will be available, as source code, that is. And some of it is going to be part of the product, like the benchmark tool which we built, for example. And then there are a lot of support we're adding for operators. Essentially, the AS/ADM tool is being streamlined. We will be enhancing the AS backup over time. But finally, we will also build out a REST API admin library to expose some of these, pretty much all of the features that are now available only through the operator. We will make them available through a REST API. And this is going to be easier for any of our customers to integrate with their own what I would call operational paradigms, which are not necessarily fitting into the standards that other people are using. Finally, all of this work that we're doing is fairly innovative over the years, as you have noticed. And I'd like to talk a little bit and close by pointing out the customer impact of these innovations. First of all, our customers have benefited from using Aerospike, especially those who have had enormous growth. You know, one of the early kind of philosophies of Aerospike is our ability to enable customers to achieve what we called was quote unquote Google scale for anybody. So we wanted to make it available for any customer, and that's something we have done in various areas. You know, especially you can see this here. You know, PayPal has been using us for their fraud detection for real-time transactions. Wayfair is using us for recommendations. You know, Experian is using us for our cloud service on financial transactions. You know, PubMatic and Playtika actually recently went IPO, but they have been long-term customers who have benefited from some of the advances we made. You know, the European Central Bank uses our strong consistency distributed cluster architecture that we released as part of Database 5 last year. Verizon Media is actually modernizing some of their key value stores by replacing them by Aerospike across the board. You know, Airtel and various other telcos are also using Aerospike in various areas. So, and the Trade Desk has been a user of Aerospike for over 10 years now. And the point is, all of these customers have basically grown enormously over the years, and they have benefited from the fact that Aerospike is able to continue to scale as a real-time data platform that is used for billions of transactions at petabyte scale. Thank you.
Thank you, Srini, for your review of the Aerospike innovation agenda, and particularly your comments about today's news about 5.6. You know, you positioned all that under the term query. And I think when people hear the word query, something jumps to mind. So I'm gonna throw you a question that I know you get a lot about, and it's what's Aerospike's position on SQL? When you hear query, I think a lot of people think SQL. So I know you have a perspective on how we support SQL. Maybe you could dig into that a bit.
Right. Aerospike, as you know, essentially has optimized certain transaction paths and indexing technologies using various storage technologies. We are going to stay focused on the core and enhance our ability to access this data. Our path to SQL is through some of these basic work that we're doing on indexing and how we integrate it with systems like Presto. We recently released a JDBC driver, for example. So you would expect us to support SQL through systems which handle SQL well and translate it to Aerospike APIs, which work really well, and we enhance our query capabilities, as I spoke about today.
Terrific. Another sort of question that comes up a lot is Spark, you know, and I know we've had an Aerospike Connect for Spark product for some time now. There's a lot of questions about what do we really do to enhance the performance of Spark. I think there's some unique things that we do to make Spark perform better. Maybe you can dig into that a little bit more than you did in your remarks earlier.
Right. So the key is parallel access, you know, in terms of how we can divide and conquer in terms of processing. So what Spark typically does is it processes data which is in its memory. And what Aerospike can do is expand the amount of data available to Spark more than what's available in memory. And the parallel access that Aerospike provides in terms of scanning, because Aerospike has a natural way to partition data to 4,000 partitions, but on top of that, we are able to start and stop scans from specific points within a partition. So you could essentially align thousands of Spark workers, you know, and divide each of the worker to a portion of the data in Aerospike. And thus, you can fetch the data just in time from Aerospike into Spark to do the processing and then go on to the next record. Doing this kind of processing means you could potentially process 100 terabytes in under a couple of hours. And that's the kind of power we can provide Spark processes.
Terrific. So you made a comment about cloud in your remarks as well, in our direction on cloud. And we've heard from the trade desk about cloud versus on-prem. We're going to hear from Adobe about running us in Azure, and Maven about running us in GCP. What's your take on cloud, and what do you hear from customers in terms of public, private, multi-cloud? What is your take?
We actually hear all of it, in the sense that there are a number of customers moving from one cloud to another, people who are moving from data center to the cloud, and then there are customers who actually move down from cloud to a data center. You probably saw a talk in the conference on that. Now, our position in Aerospike is we will work on commodity hardware, and we'll make our product work with the latest and greatest technologies. So we're agnostic in terms of cloud, and we are cross-cloud, inter-cloud. All kinds of deployments are possible with Aerospike. Even splitting a cluster or stretching a cluster across clouds is also possible, or use XDR to communicate between clusters and so on.
Terrific. Well, it looks like we're out of time. I want to thank you, Srini, as always, and thanks everybody for attending today, and enjoy the rest of the summit sessions.
Thank you, Bill.
Thank you.